students, welcome to the chemistry class. For this session, we are going to discuss the topic energies of orbital. Okay. First part, I recall the previous session. So in the previous session, talk about the orbitals, shape of orbitals. Totally that is 4 orbitals, s orbital, p orbital, d orbital and f orbital. Now I am writing in the tabular column format. Compare and study. This tabular column is helpful for you. So students, take the notes. Okay. So now see the board. Now here n value is equal to 1. Here n value is equal to 2. Here n value is equal to 3. Here n value is equal to 4. This one denoted, that is s orbital, started from the first shell. Nucleus, first shell s orbital started. N is equal to 2. So p orbital is starting from second shell. N is equal to 2. And third one it's starting from third shell. It contains, that is a subcell. This one for orbit. So in the orbit contain the subcells or orbitals. So here only S alone. In second one S as well as P. Third one S, P and D. So we are writing N is equal to 3. Next one S, P, D and F. Fourth cell. So N is equal to 4. So now you know the formula. L is equal to n minus 1. So 0, 1, 2, here 3. M formula minus L, 0 plus L. So write the value. Here 0, so 0. Here 1, minus 1, 0 plus 1. Minus 2, minus 1, 0 plus 1 plus 2. Minus 3, minus 2, minus 1, 0 plus 1 plus 2 plus 3. Next one, talk about the orientation. S orbital, one orientation. That represented as only one box. Here 3 orientation in p orbital. 3 orientation. Here 5 orientation in f orbital. 7 orientation. Here how many electron it is possible if we counted mean s orbital 2 electron, p orbital 6 electron, d orbital 10 electron, f orbital 14 electron. Next to calculate the nodal. Here s orbital is a spherical shape. So uniform, that is distributed electron in the within the sphere. Okay. So here no nodal plane. Here only one nodal plane, 2 nodal plane and 3 nodal plane. Okay. So next one, s orbital shape, spherical shape. P orbital dumbbell shape. In d orbital totally 5 orientation. 4 the shape is the 4th orbital. The shape is clever leaf. Last one dz square shape is dumbbell with definite electron cloud. So in f orbital it is very complicated children. So I am writing here. Okay. So this is the shortcut method to study the shape of orbital. So noting the shape of orbital tabular column. Okay children. For this session now discussing the topic energy of orbitals. So orbitals you know very well. What about the orbital? S orbital, P orbital, D orbital and F orbital. So now talk about the orbitals, energy levels. Children, now see the topic energies of orbitals. Okay children. So center nucleus, first shell. Okay. Here is closer to the nucleus. Now n is equal to 1. Next one n is equal to 2 and n equal to 3. So now talk about the electron. The first shell electron it is present. Okay. So it has some that is amount of energy. Now it is closer to the nucleus. So how more attraction takes place. And next one, now if the electron it is present here, now the distance increases. Okay. So now what about the energy? This energy also increases. Now take the n is equal to 3 if electron it is present here. So now what about the energy? Energy level increases. So this one it depends on the n value. What is n? N is the principal quantum number. So this energies of the electron depending upon the principal quantum number if variation takes place. Okay. So now n is equal to 4. Energy level increases. N is equal to 5. Now the energy level it is increases. So now here this n is equal to n value, principal quantum number increases, the energy increases. But at the same time, what about the attraction? That is less. Now it is closer to the nucleus, so more attraction. Okay, so now n is equal to 3 or 4. Now the attraction is less. This is a general concept, children. Here it is classified in two ways. One is one electron system and another one is multi-electron system. So one electron system means the element contain one electron. So example, hydrogen, H, atomic number 1, number of electron 1, number of proton 1. Okay, so multi-electron means more than 1. Okay, so lithium, beryllium, whatever, so remaining except the hydrogen remaining, it comes under the multi-electron system. So now talk about one electron of hydrogen atom, talk about the energies of orbitals. Okay, so one electron means now this is the first shell, n is equal to 1. Here electron it is present. Now it is the electron, it revolves around the nucleus in a spherical path. Okay, so it is the s orbital is the spherical shape. So it moves in the spherical path, the electron it is moved. So here even in the 360 degree the electron it is present. Okay, so now the more attraction takes place between the nucleus as well as electron. Okay, so now here the energies, that is the arrangement is like that. This one increasing order of energy. Okay, so first shell 1s orbital and second one 2s orbital and 2p orbital. In this one for n is equal to 2. This one n is equal to 1. Next 3s, 3p and 3d. Here n is equal to 3. Okay, so next 4s, 4p, 4d and 4f. For n is equal to 4th shell. N is equal to 1, 1s. N is equal to 2, here 2. This one for orbit is revolved around this circular path is known as orbit. So this orbit contains subcells. Okay, all orbitals. So here only 1. So 1s. N is equal to 2. So 2 orbital it is present. One is s orbital and another one is p orbital. But s orbital shape is spherical. P orbital shape is dumbbell shape. Even it present in the same energy levels. Okay, here electron movements in circular, spherical in shape. Here electron move in the dumbbell. That means electron present only here. Okay, so even here absence of electron, that is angular distribution is 0. Okay, so same way n is equal to 3. Here s orbital, p orbital, d orbital. Here n is equal to 4. S orbital, p orbital, d as well as f orbital. So based on this, that is the energies of electron present like that. Are you clear, children? Especially for one electron system. Okay, so now here electron it is present in n is equal to 1. It is denoted as ground state. Ground state. Now maybe if apply any electromagnetic radiation on the electron, it move to the next energy level. That means here this electron is shifted, okay, or jumping. So now jumping means here the electron reaches 2s orbitals, this energy level. So now the energy level that is increases. Okay, so now this electron is wave character, wave in nature. So it is not present here. So it will come back again the same energy level. Okay, so now this electron jumping here. So this process is known as excited state. Okay, so here classified as two. One is ground state. It present as a particular place, that is ground state. Now the electron gain energy and move to the next level. We call it as excited state. Are you clear, children? Okay. So now here electron it is present in 2s and 2p. So the same energy level it is present. So it is called as degenerate state. That is denoted as same energy level. S orbital as well as p orbital, both also it is present in same energy levels. Children, here talk about the orbital energies. Okay, it is explained based on two methods. One is one electron system and another one is multi-electron system. In one electron system, take the example hydrogen. Okay, so in the hydrogen, the arrangements like that. But in multi-electron, it is not suitable for this pattern. Okay, so some deviation it occurs. So why this deviation it occurs? Now we see. Children, so in the one electron system, the order is like that. Oneness. Okay, so next one, 2s equal to 2p. Next, this because this 2s and 2p is present in the same energy levels. Next, 3s equal to 3p equal to 3d. Next, this one, 4s equal to 4p. Why writing equal symbol? Same energy level it is denoted. 4d equal to 4f. This is the order for one electron system. So this order is not possible for multi-electron system. Okay, so in multi-electron system, to follow the energy level like this: 1s, 2s, 2p, 3s, 3p, 4s and 3d. Here also it is variation. Okay, so first question, why this variation it occurs? So here are three reasons. Based on this three, the energy level it is splitted. But in one electron system, 2s and 2p same energy level. But in multi-electron system, now 2s is lower. Okay, but 2p is higher energy levels. Very clear, children? Same way for 3s, 3p, but 3d present here in between 4s orbital. Are you clear, children? So now why this way? First question, why this variation it occurs? Reason number 1. Okay, first point. Now nucleus is present at the center of the atom. Electron is revolved around this nucleus. Now take the 1s orbital. Here electron, 1s orbital, 2 electron it is present. So this 2 electron it is closer to the nucleus. Nucleus, what is the charges? Positive. What about the electron charges? Negative. So positive, negative attraction takes place. Okay, so now due to attraction, the energy is very less in 1s orbital. So next 2s orbital, so next level here. Okay, so 2s orbital. Now the distance that is increases. So now the energy slightly it increases. Okay, so next point, in 2p as well as 3p, now the energy level is increases. Why energy level is increases mean? Now take the second. N is equal to 2. Here electron it is present. Here how many electron? 8 electron it is present. Okay, 8 electron present. So now this n is equal to 1 as well as n is equal to 1. Electron it is present. Electron negative charge. This electron also, what about the charges? Negative charge. So now electron repulsion, because it has same charge both also. So point number 2, first one, attraction. Okay. Second one, repulsion takes place between these two levels, two orbitals, n is equal to 1 as well as n is equal to 2. So third one, talk about the shape of orbital. Here s orbital, it is the spherical in shape. So spherical shape means here the whole within the sphere electron is present, is anywhere. But in p orbital it is dumbbell shape. Electron it present particularly in the lobe only. Here are two lobe. Okay, this is the nodal point. Even here the electron it is absent. Okay, so due to this reason also, now the energy level that is splitted. Okay, children. Okay, so next one here, let's take the next n is equal to 3. So again that is electron that is increases or repulsion takes place. Now to note the next here, what about the attraction? Okay, here the attraction is very less. Okay, why the attraction is very less mean, in between here two shell it is present, two shell also it is electron it is present. So now this two shell here it act as a shield, so less attraction. Okay, but at the same time energy level increases. So this less attraction due to this electron it is present, so it behaves as the shield. Okay, shield means just cover it. Okay, so attraction it is very less. So this process here it is known as shielding effect. Okay, so next one here, totally orbital, s orbital, p orbital, d orbital and f orbital. So four orbitals we discussed here. So among this, which one is more shielding mean s orbital is more shielding. Next p orbital, d orbital and f orbital. But in energy level, see here which one is the highest one, f orbital. Reverse process. Okay, energy level, that here shielding, based on the shielding, s orbital is more shielded, it closer to the nucleus. In energy level, s, p, d and f. So f orbital the highest energy level because it present here. Okay, the fifth cell f orbital, fourth cell that is f orbital it is present. So energy level it is increases. This is denoted as shielding. Can you, I hope children you can understand here. So due to this reason, now in multi-electron system, the orbital splitted in energy levels. Okay, energy level it is splitted. But in one electron system, to follow this order only. But in multi-electron system, now to follow this order. So 1s, 2s, 2p. Okay. So next one here, to fill the electron based on n plus L rule. So what is n plus L? N denoted as principal quantum number. L denoted as azimuthal quantum number. So the sum of principal as well as azimuthal quantum number to decide based on this to fill the electron. Children, I give one example. For example, carbon. Atomic number 6. Now write the electronic configuration. Okay, till you are take them practice for 2, 4. But here in higher classes, we want to write the electronic configuration like this pattern. 1s 2, 2s 2 and 2p2. So how we are writing this pattern? Now I am explaining. This is the fundamental, children. So listen carefully. So this 1s, 2s and 2p. So this that is order, it is based on n plus L rule. Okay, so now see what is n plus L rule. Now write the tabular column to find out n plus L value. Okay, so this alone it is helpful to write the order energy of orbitals. Okay, so 1s, 2s, 2p, 3s, 3p, 3d. The series you know very well. Okay, children. 4s, 4p, 4d, 4f. 5s, 5p, 5d and 5. So first write the orbitals. Okay, so this orbitals you know very well. Nucleus, first shell, n is equal to 1, s orbital. So 1s. Next, n is equal to 2. n equal to 2. Here s orbital as well as p. So 2s and 2p. Next third, n is equal to 3. Here s orbital, p orbital, d orbital. 3s, 3p, 3d. Okay children. Next fourth, n is equal to 4. S orbital, p, d and f. So 4s, 4p, 4d and 4f. Next level, n is equal to 5. S, p, d and f. So S, p, d and f. Are you clear children? So this one easily remember that. Okay. So now first write the principal quantum number value. So principal quantum number means denoted as the shell. N is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4, n is equal to 5. So now to fill the principal quantum number for 1s orbital. Here 1, n principal quantum number. So this number right here. Next children, this tabular column maximum for all the video I am writing this tabular column children is very important tabular column. Okay. Now L azimuthal quantum number value 0. What about the orbital? S orbital. L is equal to 1 p orbital. L is equal to 2 d orbital. Next f orbital. S p d f. Okay. So now L value here 0. 1 plus 0 1. Okay. So 1s orbital. Next here 2 shell. Okay. Second cell. S orbital 0. So here writing 2s. Next one here 2 L value. Now p orbital. So L value 1. So 1. So now n plus L value is 3s. Okay. So next in 3s here write 3 s orbital 0. So write. So 3 plus 0 here 3. So here 3s. And next here 3 p orbital 1. So 3 plus 1 4. Okay. So 4. In n plus L only just write the total numbers alone on write. Okay. Don't write SP and. So 1 plus 0 1, 2 plus 0 2, 2 plus 1 3, 3, 3 plus 1 4. Okay. So now first write. Fill the L. D orbital. So D orbital means here 2. S orbital 0. P orbital 1. D orbital 2. F orbital 3. S orbital 0. P orbital 1. D orbital 2. F orbital 3. Okay. So here 3 plus 2 5. Okay. 5. Here 4. 4 plus 1 5. 4 plus 2 6. 4 plus 3 7. 5, 5, 1, 6, 5, 2, 8. Okay. So now I am writing the rule here. First, wanted to follow the 2 rule. Whenever to write the n plus L order, point number 1, the electron first occupy that orbital for which n plus L value is lowest. Okay. So now 1 is the lowest one. So first we started 1 only. Next 2, 3, 4, etc. Okay. So once again, the electron first occupy the orbital for which n plus L value is lowest. Rule number 2, when n plus L value for 2 orbitals are equal. 2 orbitals are equal. See here 2p orbital and 3p orbital. Here values are equal. Here also 3, here also 3. Equal, then electron first occupy with a lower value of n. Here 3, 3. So first which one want to write? Among this n value, which one the n value is lower value? Write first. So here n value 2. So this one write first. Next want to write the 3s orbital. So whenever writing the order, you must keep this 2 rule. Okay. Once again, electron first occupy orbital for which n plus n value is lowest. First write in the lowest value. Next one write in the highest. Okay. So second one, If both n plus l value same for two orbitals are equal, now to follow the lower value of n, want to write first, next want to write in the higher one. Now write based on n plus l rule, write the energies of orbitals. Okay, so now you know the rule also. So first one want to write the lowest. So put the tick. First want to write here. What about this 1s orbital? So this is the lowest one. Okay, so second one 2. So 2 opposite here 2s. Next both also same. So now you have doubt which one want to write first. So to follow the rule, lower value of n. So first write 2p. Okay. Next want to write 3s. So now 3 over. Next take the 4 as well as 4. Okay. This 2, 4. So now here which one is the lowest value of n? This alone. Okay. So now write 3p. Next 4s. Okay, now 4 was over. Next one take the fifth n plus l value 5 and 5. Here also have 1 5. Are you clear, children? This is very important. Okay, so now here n value is lowest 3. Here n value 4. Here n value 5. So first, second and third. Okay, so now 3D. So next one 4p. Next 5s. Are you clear, children? So next take the sixth one 6 as well as 6. So here n value 4, here n value 5. So first write this one. So 4d. Okay, 4d. Next here 5p. So this is the way to write the orbital. Children, now I give one example. Take the nitrogen element, nitrogen, atomic number 7. Okay, now write the electronic configuration. But actually, I want to take the next topic also, half of Pauli-Hans rule. Okay, so now I give the practice. Okay, even now you can understand why I am writing this mean. Now write the electronic configuration for nitrogen. First, the lowest orbital, one write 1s orbital. Here number of electrons 7. Okay. So s orbital, how many electron it is possible? Only 2. Next 2s orbital. S orbital only 2 electron. Even from the beginning the tabular column writing number of electron 2. Okay. So s orbital only 2. Now to count this 2 plus 2 4. Remaining how many? 3 electron wanted to fill. So next one 2p. Okay, 2p 6 electron it is possible, but here we need only 3 electron, that's all. So 2 4 3 totally 7. So 2 electron 3 electron. So this is the way to write the electronic configuration. So we studied this topic. Okay, so now you can understand why we studied this such and such energies of orbitals. So this one alone it is very helpful for you. So it is very important area, children. So first write 1s, second write 2s, next to 2p. So each orbital, how many electron it is possible? Keep in your mind s orbital 2. Okay, so here s orbital 2 electron, all the s orbital 2 electron, 2 electron, 2 electron, 2 electron. P orbital, how many electron it is possible? 6 electron, 6 electron, 6 electron. Okay, P orbital. D orbital, how many electron it is possible? 10 electron, 10 electron it is possible. It is possible 10 electron, but depending upon the place, we need how many that is to fill here. Can you understand, children? In p orbital 6 electron it is possible, but in nitrogen we need only 3 electrons. So we write the 3 electrons only. So this is the way to write the electronic configuration. Okay, children, now come to the point. So multi-electron system. So the energies of orbital order is like that. But in oneness, what is the order? You know very well. Okay, so in one electron system the order is oneness. Okay, next 2 is equal to 2p. Next 3s equal to 3p equal to 3d. Okay, so next 4s equal to 4p equal to 4d equal to 4f. So this is the order for one electron system. So this one electron system, it is not suitable for the multi-electron system. So in multi-electron system, follow the n plus L rule and write the energies of orbital. So this is the correct order. So based on this, writing the electronic configuration. We come to the end of the session. For this session, see the topic energies of orbital. Okay, orbitals, 4 orbital S, P, D, F. Okay, discuss the energy. So from the nucleus, now n value increases, that is principal quantum number, n denoted as principal quantum number increases, energy also increases. Keep in your mind. Okay, so here this energies of orbital is explained based on one electron system as well as multi-electron system. One electron system is only applicable for hydrogen. One electron, element contain one electron. This is the order. Okay, so in multi-electron system, the order it is changed. It cannot be follow the one electron system. We know the reason, 3 reasons. One is based on the shape and another one is attraction as well as the repulsion concept. So the order, the energy level is variation, to occurs the variation. And next one, this arrangement, it is based on the n plus L rule. Okay, so now I am writing the orbitals and write the n value as well as L value to put the total within the total. Now to follow the rule. How to rule? Okay, rule number 1, first write the lowest energy level. Rule number 2, if both also same, okay, but the orbital, which orbital want to write first? N value, which one is the lowest value? Write first. Okay, children. And next one, in one electron system, the energy value is calculated based on this formula, minus 1312.8 Z square by N square. Z denoted as the atomic number, N denoted as the principal quantum number. Kilojoule per mole is the unit of energies of nth orbit. Very clear, children? Children, I hope you understand this session. And now to start practice, children, write the electronic configuration. Okay.